everyone. Today in this video clip, I'm going to go over sections 6.1 all the way to 6.3 in our textbook. 6.1 is about our inverse trig functions, and 6.2 and 6.3 is about how to solve for equations involving trigonometry. So we call it trig equations. Okay. So let's start with 6.1, inverse trig functions. So recall that you have a trig function, say y equal to cosine x. Okay. So here x, think of it as an input and y is output. Every value plug in for x, you got y come out, the output y come out. And the inverse of this means what? We're going to interchange the role of input and output. So the inverse is going to be this. Inverse is going to be x equal to cosine y. See, x becomes y and y becomes x. So instead of writing the inverse function this way, we have two ways to represent the inverse function. Either writing y equal to cosine inverse of x, okay, just like our normal inverse notation, inverse function notation that you learn in college algebra, or you can write y equal to r cosine of x. Either way, both way writing right here means that line right here. So y equal to cosine inverse of x means x equal to cosine of y, or y equal to r cosine of x is also mean x equal to cosine of y. But we have to check for the condition to have the inverse, because we only have the inverse function if the original function is 1-to-1. However, the function y equal to cosine x is not 1-to-1 actually. This function looks like this. Okay? Okay? So it fails the horizontal line test. It's not 1-to-1. So we have to restrict the domain of the cosine function, the original function, to make it 1-to-1. So instead of having the entire domain from negative to positive infinity, we restrict it from just 0 to pi. 0 right here, pi right here. So if you restrict x from 0 to pi, now our function is only that much. Only that much. Now it's going to pass the horizontal line test. It's going to have the inverse function. And of course, x for the original function is from 0 to pi, and y here now turns out to be the range. It's going to be from 0 to pi as well. Okay? And similarly for sine, cosine, this is cosine already, sine, tangent, cotangent, secant, cosecant. So let's make it easier. Let me just make a table, okay, of the domain and range of the inverse function. So we have a couple of inverse functions. Y equal to sine inverse of x, y equal to sine inverse of x. Remind you the cosine inverse, I mean. Sometime our book use this notation, some other time they use arc sine, not cosine. I claim it's the same, okay? I'll just stick with this for now. Y equal to tangent inverse of x, y equal to cotangent inverse of x, y equal to secant inverse of x, and y equal to cosecant inverse of x. Those are your trig inverse. And by the way, this means what? X equal to sine y. This means what? X equal to cosine y. This means x equal to tangent y. So forth and so on. And the domain is this. Oh, so let me erase that part. Okay. This is the inverse trig function. We talk about the domain, and then talk about the range. Okay? So your domain for the sine inverse functions is going to be negative 1-to-1, including the endpoints. You see what? X equal to sine y, right? So x is the input, so in the domain. X, you look right here. X equal to sine y. You see y? And the angle that you put in for y, the value of x is always somewhere between negative 1 and 1. So this is the domain. And the range for the sine inverse function is negative pi over 2 over 2. Keep in mind this y now is the angle. Okay? For the domain for the cosine inverse is still -1 to 1, and the range is 0 to pi. This is pi over 2 pi. I wrote it wrong. Less than or equal to pi. For tangent inverse, the domain is from negative to positive infinity. Okay, and the range is from negative pi over 2 to pi over 2, but not include the endpoint. So negative pi over 2 less than y less than pi over 2, but not including the endpoint. And let's recall the graph of tangents. This is negative pi over 2 right here. This is pi over 2 right here. Okay, and the graph looks like this. You see, x is anything from negative pi over 2 to pi over 2, but not negative pi over 2, not pi over 2. Y is from negative infinity to positive infinity. So the inverse of it, we change x to y and y to x. So now x is from negative to positive infinity, and y from negative pi over 2 to pi over 2. That was the idea. Okay. And then cotangents, same thing, negative infinity to infinity. But this changed a little, just from 0 to pi. Okay. And then for secant inverse, secant is one of a cosine, so cosine, right? So the domains is gonna be from anything cosine is anything but pi over 2. So what? 0 to pi over 2 union pi over 2 to pi. See, you got a square bracket right here. Okay, and this is parenthesis. Okay. I'm sorry, I wrote it wrong. It's going to be the range, not the domain. This is right here. 0 to pi over 2, and union from pi over 2 to pi. It's going to be the range. Because remember the graph of cosine, right? Yeah, the graph of cosine. Okay. And now you have this part is the secant, okay? So x is from where? From 1 to infinity. I'm sorry, y from 1 to infinity, now it's x. So it's going to be what? Negative infinity to negative 1. Then union 1 to infinity. Okay? To change the rules of x and y. And same thing here. Negative infinity to negative 1. Union 1 to infinity. And the range for cosecant is 1 over sine, so sine cannot be equal to 0 at 0, so it's going to be negative pi over 2 all the way to 0, but not including 0, then 0 to pi over 2. Alright? So this table will tell you everything about the domain and range of all the 6 strict functions, inverse function. Okay, so pretty much this is the end of the first section, but I think I should give you a couple example easy one. So say you got y equal to tangent inverse of root 3. Can you solve for y? What does it mean by this? It means root 3 equal to tangent of y, right? You ask yourself, what angle make tangent equal to root 3? Okay? What angle make tangent equal to root 3? I don't know, so I draw the unit circle right here. Okay, tangent right here, root 3 is about this. So it's going to be 60 degrees. 60 degrees is pi over 3. So y equal to pi over 3. And don't forget to check to see if it's in the range. So tangent inverse is right here. Yes. Pi over 3 is somewhere between negative pi over 2 to pi over 2. Okay? It's just an example. How about another one? How about y equal to sine inverse of 1/2? In other words, say what? What angle makes sine equal to 1/2, right? And this really means this is sine inverse of 1/2, right? So what? 1/2 equal to sine y. Okay, see? What angle makes sine equal to 1/2? So sine y equal to 1/2. What is y equal to? What angle makes sine equal to 1/2, guys? I think it's 60 degrees, so y equal to pi over 3. Okay, actually there's a couple angles that's got sine equal to 1/2. This is angle pi over 3, and this angle right here is also is 2 pi over 3. But we have to look for our range, okay? Sine inverse right here. It's negative pi over 2 to pi over 2. So it's all the way from here to here, so we only take pi over 3. Alright? And of course, same thing for the other angles. And this first section, 6.1, is to prepare you guys to the next two sections of 6.2 and 6.3. We're going to solve for a bunch of equations involving sine and cosine. And let me just cover the next two sections by showing you a bunch of examples, okay? Hopefully we have enough examples to help you to get the idea of how to solve for trig equation. Trig here means the regular trig and the inverse trig equation as well. Okay, so let's move on. Trigonometric equation. Okay, 6.2 and 6.3, trig equation. Okay, so let me just look at. All right, evaluate this. Let's say what? Tangents of or cosine of 3 over 4. You ask me, what is it equal to? Okay, so let me show you a very good technique that helps you to figure it out. Whenever you guys use the inverse function, the main idea that you try to do, the main step you try to do is try to bring it back to our normal function. So I'm going to let y equal to arc cosine of 3 over 4. By the way, arc cosine is the same thing as cosine inverse, okay? So you let y equal to arc cosine of 3 over 4. This problem is no more than what? What is tangent of y equal to, right? Because you let the whole thing right here is y. Okay, so y equals to arc cosine of 3 over 4. You can bring it back to the regular cosine function. That means 3 over 4 is equal to cosine of y. Keep in mind that y is the angle equal to cosine of y equal to 3 over 4. Okay, and your job is to calculate tangent of y. And I urge you to practice this technique a little bit so that you master this, because I claim that for sure when you guys move on to calculus, you guys are going to use them again. All right, and use the right triangle in here. If you have the angle y here, and you know that cosine is opposite over, cosine is adjacent over hypotenuse. So adjacent is 3, hypotenuse is 4, and cosine of y is 3 over 4. And with this, you can calculate the other side, the opposite side, using the diagonal theorem. This is 4, this is 3, so this side going to be 4 squared is 16 minus 9, 16 minus 7, so this is square root of 7. Okay, 4 squared minus 3 squared, 16 minus 9 equal to 7. This side is square root of 7. Okay, now it's good enough for you to calculate tangent of y. What is tangent? Tangent is opposite over adjacent. So tangent of y equal to square root of 7 over 3. And then let me double check on the question, see. Yeah, that's it. Okay. Try another one. A little bit harder. Try this. I see this. Sine of 2 tangent inverse. Sine of 2 tangent inverse of 12 over 5. Okay? And what is it equal to? That was the question. Again, you let the inverse function equal to something. Let, actually you have two ways here. You can let y equal to tangent inverse of 12 over 5, or you can let y equal to 2 times the whole thing. So let me start with this way first. Y equal to tangent inverse of 12 over 5. So this problem becomes what? Sine of 2y, right? I got 2 right here, so sine of 2y. So I see that I got a double angle right here. So I can bring it back to the single angle. Sine of 2y is 2 times sine y cosine y. Okay? And we calculate right here. Tangent inverse of 12 over 5 is y, so 12 over 5 equal to tangent of y. And again, same old trick. We use the right triangle. The angle is y right here, and I know the tangent is opposite over adjacent. So this is 12 opposite. This is 5 right here. So I can calculate the hypotenuse. 12 square is 144. And 5 square is 25. 144 plus 25 is 169. So this is 13. 13 square is 169. I got a complete right triangle. So I can calculate sine and cosine. So sine of y, sine is opposite over hypotenuse. So 12 over 13. And cosine of y is adjacent over hypotenuse. So 5 over 13. So we have what? This is 2 times 12 over 13 times 5 over 13. You have 120 over 169. Okay? Hopefully that helps. And of course, same idea. You see other problems, you pretty much do the same way. Let's try another one. I see another one. I think it's a bit harder. Okay. Okay. We have cosine of tangent inverse of 5 over 12 minus tangent inverse of 3 over 4. Tangent inverse of 3 over 4. So what's the difference in here? You guys see that we actually have 2 inverse trig functions. So we have to do 2 sub, okay? So I'll do u and v. Let u equal to tangent inverse of 5 over 12. And I let v equal to tangent inverse of 3 over 4. So this problem becomes what? Cosine of u minus v. Now you see what? Cosine of different 2 angles. You have the formula for cosine of u minus v is cosine u cosine v plus sine u sine v, right? Times cosine v plus sine u sine v. So you have to calculate all u and v right here. And of course, same trick, but you got to do it twice because you have 2 sub. For the first one, I'm going to draw the right triangle. The angle is right here is u. Oop, I have to convert it back. This means what? 5 over 12 is equal to tangent of u. So tangent is opposite over adjacent. So 5 here, 12 here. 5 is 12. This is 13. We just calculated it. And then this is what? 3 over 4 is tangent of v. And I draw another right triangle. This is v right here. Opposite is 3, adjacent is 4, so this is 5. So we have everything. So we calculate cosine of u. Cosine of u, cosine is 12 over 13, and sine of u is 5 over 13. This one right here give me cosine of v is 4 over 5, and sine of v is 3 over 5. Okay? Now plug them all in here, you have the answer. Cosine of u, 12 over 13, and cosine of v is 4 over 5, and plus sine of u is 5 over 13, sine of v is 3 over 5, so this is what? 48 plus 15 over 65, which is 63 over 65. If you have 3 examples, hopefully it's help you to understand how we get the trig equation involving regular trig and the inverse trig function. So let me move on to another type. Now, we solve the equations, okay? There's a lot of equations to solve, so I'll just randomly choose a couple of those. Start from easy to hard one. This requires practice, guys. I cannot give you every single problem in the book. I'll just show you some typical equations and some general ways of solving. And then when you practice, you're going to gain experience by yourself. So I got this. How about this? Just randomly choose one. 2 cotangent of x plus 1 equal to -1. Okay? Solve for x. That's the question. So what I see in here, I only have one trig function, which is cotangent, and then the angle is simple, just x, no double, no half angle, nothing. So I can isolate the cotangent on one side. Subtract the 1 on both sides. I got 2 cotangent of x equal to -2, -1 here, -1 here. And then divide both sides by 2. Divide both sides by 2, I got cotangent of x equal to -1. Alright? And now you ask yourself, what angle make cotangent equal to -1? This is cotangent. Cotangent is right here, -1, so the angle is going to be, what was that? From here to here, 45 degrees plus 90 is 3 pi over 4. Yeah. So x is equal to 3 pi over 4. Or if you're talking about from -pi over 2 to pi over 2 right here, and the angle right here, x equal to -pi over 4. Okay, so which one is the domain? This depends on the question. Say what? The answer is something between 0 and 2 pi. So they have to give you a condition, all right? They tell you what? I want the x is somewhere between 0 to 2 pi. Then you choose this answer. What if in the question they ask you what? I want the answer is somewhere between -pi over 2. This is 0. 2, say pi over 2. Then you have this answer. Hang on. 0 to 2 pi, right? This is one answer right here. And go back here. There's another answer. For 0 to 2 pi. This is 3 pi over 4. And then what? 7 pi over 4. And then 7 pi over 4. See why I got 7 pi over 4? This is 0 right here, pi over 2, 3 pi over 2. I got, this is -1 for cotangent. Okay? And then I go all the way down here. I still have cotangent equal to -1. Okay? So in general, if you have cotangent of x equal to -1, this is how you should write, but I don't think that's the book. Try to write this a lot, but x is equal to, see right here, 3 pi over 4, which is a point right here. You keep adding 1 pi to it. Okay? So what? Plus k times pi, where pi is 3.14 and k is the counting number, 1, 2, 3, and -1, -2. Okay? K equal to -2, -1, 0, 1, 2. Alright, this one. And then depends on the interval, you plug in the k value, you have the answer. In our problem right here, if they say that x is between 0 and 2 pi, you have two values. 3 pi over 4 and 7 pi over 4. Alright? Try another one. How about this? 2 sine theta minus 1. 2 sine theta minus 1 equal to cosecant theta. And the question asks you to find all the solutions somewhere between 0 to 2 pi. 0 less than or equal to theta, less than or equal to 2 pi. Okay? Find all the solution. So looking at the problem, the good thing is what? It's only have angle theta. No double angle, no half angle, no triple angle, which is good. But you have two types of trig function, sine and cosecant. And in general, I tend to try to bring it back to either sine or cosine, and that would be a very good move, even though it may not work 100% of the time, but I would say 80% of the time it seems good. So 2 sine theta minus 1, and cosecant is 1 over sine. Yeah, so 1 over sine theta. Now that I don't have two trig function anymore, I only have sine in here, and I can solve. So how do I do? Get rid of fraction. How can I do that? Multiply both sides by sine theta. So I got 2 sine square theta minus sine theta equal to 1. I am multiplying both sides by sine theta. I'm just trying to get rid of the fraction. Now I have this. Now I see that I have a quadratic, right? Sine square, sine, and 1, so what? Bring everything to one side. 2 sine square theta minus sine theta minus 1 equal to 0. You think of the whole thing sine theta as a variable, so like kind of 2x squared minus x minus 1 equal to 0. Kind of like this when x equal to sine theta. Okay, so you can either factor out or you can use a quadratic formula to solve. But I think this one is factorable, so let me factor out. I got what? 2 sine theta times something, and then sine theta something in here. I think this minus 1 in here, so this is plus 1. Check it out. 2 sine theta square minus 2 sine theta plus 1 sine theta. Yes, perfect. It's equal to 0. All right. So you have what? Brought up 2 factors equal to 0. So either one of those 2 factors is going to be equal to 0. So either 2 sine theta plus 1 equal to 0, or sine theta minus 1 equal to 0. So in here you got either sine theta equal to 1/2, negative 1/2 I mean, or sine theta equal to 1. Now you ask yourself, what angle make sine equal to negative 1/2? So I don't remember, so I draw negative 1/2 is sine is right here. Okay, so negative 1/2 is somewhere right here, right? So theta is equal to what? The angle is 1/2 is for sine 30 degrees, right? But this is kind of 30 degrees or 180, 30 degrees pi over 6. Okay, pi over 6 plus pi is 7 pi over 6. What's the angle from here to here? 7 pi over 6. And then keep going the complete circle, so plus a multiple of 2 pi. That's the answer. Or the other one, theta, is what? This one right here is negative pi over 6 and plus a multiple of 2 pi again. Okay? And now you go back to the condition that they give you. Let's see what the angle of theta is going to be from where to where? From 0 to 2 pi, right? So obviously this angle is good, 0 to 2 pi. And then this one is also good. The first one is 7 pi over 6. The second answer is not pi over 6. It's going to be what? Negative pi over 6 plus another 2 pi. 2 pi is 12 pi over 6 minus 1 pi over 6. So we have 2 answers in here. Theta equal to 7 pi over 6, and the other one is 11 pi over 6. See, 12 pi over 6 is the whole circle. This one is negative pi over 6, so take away 1 over 6. 11 pi over 6. Move on in here. Sine theta equal to 1. You ask yourself the same question. What angle makes sine equal to 1? This is my unit circle. Sine equal to 1 if the angle is 90 degrees. Yeah. So theta is equal to pi over 2, right? And then plus k2 pi. K2 pi means what? A multiple of 2 pi. You keep going back, you have the same sine function. Okay, but our angle theta is going to be somewhere between 0 and 2 pi, so we only have one answer, theta equal to pi over 2. So we have 3 solutions. Okay, as I say, it may be a little bit confusing, it may be a little bit difficult when you first try it, but keep practicing, okay? Nobody can get through everything right the first try, so practicing, and it's okay to get it wrong a couple first times. Okay, try more. I'll just look for another while, turn the page, something harder. Oop, one more here. Okay. Try this. Sine squared times cosine equal to cosine.